Hello, ladies and gentlemen. My name is AllenSmithwick. This is my final project for the summer 2013 course of the Digital Forensics NYU MSIA Cybersecurity Program. In this project, what we seek to do is show group policy recreation from offline DD images. Primary objective of this project is, of course, to extract and reconstruct registry keys which have been set by local and domain-based group policy elements from the offline DD images. We want to reconstruct the group policies in regards to registry-based values to determine if the value was set by a group policy and by which group policy the value was set. Secondary objective is enhance currently available USGCB or NIST spreadsheets. So we want to be able to correlate the NIST USGCB information and provide enhancements to the NIST provided spreadsheets with representation of the actual registry values which will be reflected by the group policy settings. Problems on the relying on more traditional auditing methods such as RSOP and GP result for group policy auditing is when corruption is encountered. This is mainly in WMI and or WMI filters, AD extensions, third-party extensions, invalid incorrect schema extensions, or otherwise incorrect and or malicious behavior from both human and code elements. In the event these tools cannot be used, one thing I've always wished and hoped for was a way to be able to check the registry to see what was actually set by group policy. In most cases this is simple. It's going to be enabled, disabled, which corresponds to 1-0, but however this is not always the case. Consider the following example, which is for the LAN manager authentication level. If you look at the USGCB spreadsheet, it's going to tell you that it should be set to send NTLM version 2 response only, refuse LN, and NTLM. What the spreadsheet unfortunately does not tell you is that this corresponds to the system the system current control set control LSA LM compatibility level key hyphen key. This particular setting for the USGCB defined setting would be a type regd word and a value of 5. If you look in the image on the side, you can see that there's actually 6 options, starting with a 0-byte array. It could be determined that this should be 5, but we wanted to make it much more simpler and easier than that. Some of the other objectives. Once the registry values that should be set by group policy has been identified, we want to see if the expected values matches the actual values. This validates at the time of the capture compliance status of the system in relation to group policy. So essentially there what we want to do is compare expected security versus actual security. We want to be able to analyze what the group policy should have set the value to, and then we want to check and see what the actual value was set to. It's all too common these days. Users have more privileges than what they require. Example, local admin, and can knowingly, or even worse, unknowingly, change registry keys which are applied by the group policy. In theory, by design, group policy will refresh every n minutes, default to 15, but there is a window of opportunity from an attacker's perspective, as well as several ways to just stop processing a group policy altogether. We'll not go into some of those methodologies, but they're fairly robust, and the most important thing there is that there's a window of opportunity for a hacker or attacker. Another common practice is only to enforce group policy from the domain level and not replicate the domain-based group policy as a local security policy. So in effect, when the group policy or the domain is not available, you're now relying on local security policy. If you don't have anything defined in your local security policy, then all the controls you put on the domain level have been mitigated. Some of our core challenges that we're facing. We want to be able to extract information from the POL files. POL files we'll discuss more detail here in a little bit, but what they are is essentially the local security policy instruction files. We're going to demonstrate how to use the LGPO utilities provided by NIST Microsoft. I do believe those are actually developed by NIST, but linked to very heavily by Microsoft. We're going to use these in order to translate the POL files. The POL files are binary files with a signature offset. And rather than us writing code in order to do the extraction and the translation, we're going to rely on already free and available tools in order to do that. Once the files are actually decoded, they read like an instruction file for what hives, keys, values should be created, deleted, and set. Some examples here below. You can see the create key, set key, delete key, and delete all. Important note about the delete all is it does not actually delete the hive. It only deletes all values underneath the hive. I'm sorry, all keys underneath the hive. Next biggest challenge is correlating the registry information to a group policy. Several methodologies and tools available to extract the information from offline images as well as online images. We will opt to use RedRipper running on a Linux system against a mounted DD image, and we've developed RedRipper plugins suited for our purposes. RedRipper will also tell us, the registry will also give us the history of what group policies have been applied under the GP history key, which will tell us what group policies were applied and which in order and at what time. It will unfortunately not tell us what values the actual policy set. There are other common places in group policy to set values in the registry. Policies, Windows, Windows NT are a few of the more common examples. But as we all know, group policy is fairly robust and can be configured to set values virtually anywhere within the registry. This is especially true with 2008 plus domains. With those group policies, you virtually can create a key, modify a key anywhere within the registry using group policy. The core of what we're trying to seek with this project is correlating the registry information back to the group policy. As mentioned, our challenge is that we can scan through any area within the registry. We will be able to determine which group policies have been set, in what order, and at what time. We can also find what hives, keys, and values have been set, but there is no way in the registry to correlate which group policies have set which hives, keys, and values. Well, how do you usually do that? Well, analyzing group policies is done through the more traditional methods, RSOP, GP result. But what do we do in the event that these things aren't available or not functioning, such as with WMI corruption? How can we recreate this behavior? When we start to break down how RSOP GP results work quickly, we find that the correlation lies within WMI. I'm sure there's a few people out there that have ran into this time or two in their career. When you have WMI corruption, it makes RSOP analyzation and GP result analyzation very hard to do. Sometimes you can effectively reset the WMI repository, sometimes you can't. Sometimes the policy is what's causing the corruption, so it's a cascading effect. I'm not aware of any WMI emulation tools that are out there, and when my personal view was looking through the WMI cache and the offline DB related to the WMI repository it was ineffective and incomplete. If anybody knows or cares to work on a solution for developing some form of WMI emulation, please feel free to contact me and we'll see what we can do for generation 2 of this program. But never fear, we have a way to work around it. So our solution is, in place of being able to emulate the WMI repository, what we're going to do is demonstrate how to replicate the WMI repository to a test system, so we may query the information we need for the correlation. The extraction of this information will be performed locally on the test system via Python script, and we do this in order to avoid changing anything within the actual WMI namespacing, the repository at all, in regards to setting up remote access permissions. We want to leave it intact, plus I don't know that it would actually work. Another important note here, actually never mind. Alright, so to discuss the scope of our project, we'll only be examining a DD capture from a Windows 32-bit 7 system. So 32-bit Windows 7 system. Though the script should apply to any like kernel system, 6.1 or above, which are group policy members. So, in other words, not domain controllers. It shouldn't matter if it's a server or a workstation. We just happen to be working from the workstation perspective. System has the USGCB Windows 7 computer settings and the USGCB account policy settings applied to the system both locally and through domain-based policy with no deviation from the NIST definition. We have not applied nor will attempt to extract and or analyze user-based settings, nor will we be focusing on ACLs, SASLs, or DACL permissions. Correlating the ACL, SACL, and DACL permissions without a domain controller available, more specifically a domain available, presents unique challenges in amongst itself and will be out of scope for this project. Some group membership information will be captured through the process, but we will not be a main focus of the project as well, since this ties back to ACL, SACL, and DACL orientation. Our environment is fairly flat. Everything is virtual, running in VMware Player. We have one domain controller, one target member system, and only the USGCB settings being applied. We also have another baseline Windows 7 image, which is nothing more than an updated copy of Windows 7 32-bit, which we will be using to recreate the WMI repository on. Methodology: we'll use DD for a system capture, running on a live CD, which is backtrack 5, R3, attached to the target system as a TD. Target system being our workstation that we will actually be performing the capture from. That system in particular has a second partition attached to it, which is where we'll be dumping the information. That is the only purpose for that drive. We have a separate non-live version of Backtrack 5R3, which we'll be using to perform the Red Ripper instructions, basically anything with Linux that we don't want to do on a live CD. Python scripts which are supplied will parse the provided data into an SQLite database. Main script will parse all the provided data. This is the main program that will be used. Second script is one to be used on our target system, as which we've already discussed, once the WMI repository has been recreated. We've provided SQL files which will be imported, which is a ported version of the USGCB spreadsheet in an SQLite database format. We'll also show a manual process for extracting information from the POL files, which contain settings for the local security policy. That correlates back to the POL tools that we will be using provided by NIST. As stated there, the LGPO utilities provided by NIST Microsoft. And as already stated, it's applied locally and through the domain. Going to go through some more detail quickly. All these links and information is provided in the supporting documentation for this project. I highly encourage, if you want to know more detail, you go out to these resources such as Microsoft in order to get the information rather than relying on me to be an authority in my interpretation of them. So as discussed, this is the group policy history. It's under HKey local machine, software, Microsoft Windows, current version, group policy, history. We're going to pass through this rather quickly. So just take away from the POL files that we are going to be extracting them. I'm sorry, from the GP history, we are going to be extracting that, and that will be our key indicator about which group policies were applied when and where. It will unfortunately not tell us what values have been set by which group policy, but it will tell us which group policies have been set and the history of that application. Two main places in the WMI we're going to be looking: RSOP registry policy settings and RSOP registry value settings. Settings not literal in the second one. And our POL files, of course, which we've already discussed. Main focuses of the registry that we're going to be dumping are HKey local machine software Microsoft, HKey local machine software Microsoft NT, sorry, that should be Windows NT. HKey local machine software policies, HKey local machine software, Microsoft Windows NT current version SecEdit. SecEdit was provided. I thought that was going to be more valuable than it was, but depending on what analyzation you're performing, that can still be valuable to you, so we've left it in. Alright, nothing to it but to do it. Now I'm going to demonstrate how to actually go through and do some of this stuff. First thing we're going to demonstrate is how to create our group policies. On the domain controller here, we have our USGCB group policies extracted. We're only going to focus on two, the computer settings and the account policy. So from here, we're just going to go ahead and validate that we don't have anything in the domain. If we do, we're going to delete it. Excellent. So when we join our system, we know that it's going to be joined to the computer's OU by default, and then we will apply our policies and move it to the system USGCB folder, or OU rather. Alright, so here's what we're going to do. Let's go ahead and we're going to create a policy and link it there. So USGCB account policy. Then if we go down to group policy objects, highlight the policy we just created. We're going to import settings. And that's it. Okay, great. We have our account policy settings. So now we're going to go do the computer settings. Same approach. Excellent. We now have our group policies created and attached to the OU which we want to move it to. What we're going to take a look at now is how to apply the USGCB policies to the local security policy. What we have here is just a patch system, Windows XP 32-bit. We're going to go ahead and run an elevated command prompt. First thing we're going to take a look at real quick is just an RSOP to show that there's nothing applied to the system currently. And we'll also open up the local security policy as well. So what we're taking a look here is the local security policy. We'll take a look at some of those common places. You can see a couple things are set. These are set by default, but nothing out of the ordinary, especially since we have our administrator account still being renamed administrator. So now we know there's nothing being applied on the local security policy. Let's take a look at the RSOP, see if anything's being applied for the domain. As you can see, everything is not defined, and the source GPO is blank. That is mainly because the system is not currently part of a domain. As you can see, it's still a workgroup system. So great, what we're going to do is take a look at how to apply the local policies, the USGCB computer policies and account setting policies locally. What I've done is I've copied over the USGCB policies to the local system as well as the LGPO utilities. This does not need to be done locally on the system. It's just what I prefer to do. It seems to work a lot easier and quicker. So what I'll do first is I'll show the more traditional way that you would apply these. Which we will not be using, but I will demonstrate how to do that. You go to Windows Settings, drill down on Security Settings, under the Computer Settings. You would import the policy. and you would drill down till you find the INF file that you're looking for. It's always under the SecEdit, Windows NT SecEdit, since we're only focusing on computer settings. Once you had this highlight, you would click open and it would import it to the local security policy. However, we don't want to do it that way. We want to actually use the LGPO utilities. So the first thing we're going to do is we're going to import the Windows 7 computer settings, the registry POL file. What we'll also do here, just to demonstrate, so this is under System 32, Group Policy User, or Group Policy Users. Special notice, once you apply the group policies, a lot of times these folders will become hidden. You can still access them, though. Okay, great. So as you can see under Machine, we've only got the scripts folder. No registry POL files to be heard of. So we're going to go ahead and import that. And now you can see that the registry POL has been populated. You do not need to use the tool to do that. You can just literally copy the registry.pol file and overwrite if you so desire. Next thing we're going to do is actually apply the group policy deltas. So this first one is for the account policy settings. It is now applied. And the next one we're going to apply is the Windows 7 computer account settings. That is applied as well now. Last thing we're going to do is use the set FDCC LGPO. An important note here is if you're running on XP, you need to make a few changes to the executable. So we right-click the executable and we went to Properties. First, we're going to unblock it. It's blocked since it was downloaded from the internet. We'll also need to change the compatibility mode to run in Windows XP Service Pack 3 compatibility mode. Other compatibility modes, other XP compatibility modes should work, but this is what NIST recommends, so this is what we're going to use. Excellent. Now that we've set the compatibility mode, all we need to do is run this. Great. So if you were to take a look at the RSOP and policies right now, what you would not see is anything actually being applied, even though we have imported everything. This is Windows, so we do need to do a shutdown, or a restart rather, in order to get the policies applied. So we're going to go ahead and do that. And this should be coming up shortly for us. Okay, excellent. Now we can see our system is coming back up. Maybe a little slower than normal because it does have to actually process the policies. As you notice, as we hit, well, Control-Alt-Insert in this case, but Control-Alt-Delete, we now get our banner warning message, which most of you are probably used to seeing. That is applied from the group policy. As you also notice, it did not remember who I was, so it's flipped the registry key in order to detect the last logged on user. So we're going to go ahead and elevate a command prompt again. And take a look at our local security policy now. And as you can see, the values have changed and are a little more refined. Especially the admin, which is now renamed admin, which is the default by NIST. So great, now we know that we have these policies applied locally. We're good to go. What we're going to do is go ahead and we're going to join it to our domain. I got to make some changes here just on the network side to get it to talk to the domain controller in my environment. So what I'm going to do is change the DNS stack order. In order to actually send the traffic over to our DC. So just to verify, great, we do get a return. As mentioned earlier, when we join it to the domain, it's going to be within the computers OU, right off the root of the domain. So it will not have any domain policies applied. So great, we're going to go ahead and restart the system. And let everything join to the domain properly. While this is coming back up, we're going to go ahead and take a look over at our domain controller again. As you remember, we deleted all the accounts. Okay, we still have nothing in there. Great. If we go over and look at the computers, now we have our capture box once we do a refresh. So now we know that it is joined to the domain controller, the domain rather, and it is within the computers OU. Takes a little bit longer, obviously this time, since it's now having to process communications with the domain controller. We see the same type of behavior we did before, because right now the only thing that is applied is the local security policy. So as this comes up, as you notice, desktop looks a little different. Loaded in with a domain profile now versus a local profile. Go ahead and run as administrator. And we're going to do an RSOP. We can also validate our host name. Okay, well, maybe not. We can check that through here. So it is capture box. Excellent. That's what it was. No, that wasn't what it was. Anyway, we do know that this is the correct system. We're going to take a look at this. Okay, now we've noticed that these have been changed to default domain policy. And as you can see, everything else is blanked out because that is the only thing being applied is the default domain policy, which is applied to every system. So now what we need to do is go back over to our domain controller, and we're going to move this under the USGCB computers folder. Excellent. Go back over to our system here, and we're going to do a GP update force. /force. Just as a general rule of thumb, I like to do a force and a sync in order to make sure that everything is applied properly. You don't always need to do both. The difference is that a GP update force will pull what it's supposed to have from the domain controller. It just is not able to process certain things that require logon or boot up. So now what we're going to do is a sync boot, and this will reboot the system and apply all the policies forcibly, both the foreground and the background policies. Dude, apologize about the idle silence during these times here. I was not having good luck with pausing the video using Cam Studio. So we're going to go ahead and just run through this manually, and you have to listen to some silence, unfortunately. Okay, excellent. Now our system's coming back up. It's now joined to the domain, and it should have the policies applied from the domain. Okay, excellent. Looks like we're almost there now. Please wait. We have been. Alright, excellent. Okay, excellent. Go ahead and log on here, and we're going to run another RSOP in order to verify that the domain-based policies have been applied to the system. So as you can see here now, these have changed, and the settings are being applied by the USGCB account policy and the USGCB Windows 7 settings, computer settings. So that is it for having everything defined. We now have the system, the target system, with both domain-based and local-based USGCB Windows 7 computer settings and account policy settings. Next thing for us to do is actually capture the system. Okay, now that we've got our system built and the policies applied both locally and through the domain, we need to go ahead and capture our system. First, going to make sure that I have it mounted, the Backtrack 5 GNOME 32-bit, and it's connected at power on. Go ahead and we're going to check our capture drive. I found it best in order to create that partition within Windows in order to not run into any offset problems. So yes, okay, we've got it created. We're going to format it just to make sure. As mentioned, I do this through Windows in order to avoid any MBR offset problems. Great. So now we're ready to rock and roll. We're going to go ahead and shut it down so we can go into our ISO. Another important note here, I've had varying success when if you miss the prompt to go into the live CD, my recommendation, like this, by far is to not forcibly reboot it, but to let it actually load up into Windows and do another shutdown. If you do not, sometimes it'll be sitting at the system restore settings, and that can mess up your image and analyzation at sometimes. So here shortly it should be back up, and we can trigger that to happen again. Okay, great. Now we're at the startup, so we're going to go ahead and shut it back down. And we're going to try this again. Great, made it that time. Okay, now we're going to get into Backtrack 5 Live CD. What we are going to use is DD in order to do the capture. We're not going to use any of the DoD ports of DD, such as DCD3DD or DCFLDD. Both have nice features such as hashing, progression. They're nice to use sometimes, but we're just going to keep it simple for the purposes of this project. We'll go ahead and we're going to run startx just to make it a little easier for people to see. Go ahead and we're going to install gparted real quick just to view the partitions. There are, of course, a myriad of different tools in order to do this. Whatever your flavor is, please continue to use that. We should have a disk with 3 partitions on it, all under SDA. And we do. We have a boot, we have our main disk, and we have our capture disk. Excellent. So we're going to go ahead and we're going to create a directory under Mount, FinalProject. We're going to mount our third disk, which is our capture disk, to that location. We also need to indicate a type, which is NTFS. Great. Nothing to it but to do it. We're going to tell the input file is going to be dev SDA2, and we want that to go to mount fp cap.dd, and we're going to do a byte size of 8K. You can play with the values that work best for you. Oh yes, we need to tell OF is the output file command. And now we're off to the races. First thing we're going to do is just go take a real quick look to make sure it's actually writing data, and we should be good there. Mount FP. Hey, looky there, only one file in there, and it is progressing. DD does a byte level copy, so your DD file will end up roughly about the same size as what your system was. Ours was 35 gigabits. So I'm going to go ahead and pause the video at this point, and we're going to let it generate. Okay, I skipped a little bit here since it was rather boring to watch. What I did was I allowed the DD image to complete, verified that it was done successfully, booted back into the Windows system, and simply moved that file off the capture partition to a network drive. Now what we're doing here is we're going into an actual installed version of Backtrack 5. Nothing special except that Redripper has already been installed and ported over to work on this. So we're going to go ahead and we're going to get in here. First thing we need to do is go ahead and mount our image. Okay, so we're going to make a directory, mount, FinalProject. We're going to mount as read-only. Alright, nothing special about it. So now we've got it there. Yay. Okay. What we're going to do is check and see if our plugins are already here. Okay, it does appear. Sorry about the pause there. I had to go through, just went through the file browser to sort by time. And there's the majority of our Redripper plugins already there, ready to rock and roll. So we're going to switch to the directory which contains the Redripper. Just to make sure it works, we're going to do rip.pl. Good, we do get our help file. So we're going to rip. We're going to tell it the directory, which is in our mount. Then under there, it's under Windows System 32, config, and software for the majority of what we need to extract. Most of the stuff in the system that we actually needed to extract won't show up anyway because the current control sets are blanked out when the system is powered down. So we're only going to focus on the softwares. Plugin winnt.pl. Let's just run it first. Okay, good. It does work. So we're going to port that to our output directory, where our image lives. Great. Wait, no such directory. So we've got, oh, because it was 2. Okay, beautiful. Most of these, except for the win.pl, are fairly quick. The WinNT1 that we're running now takes a little bit of time. Okay, that's done. So what we're going to do, secedit.pl. As mentioned, those are rather quick. And nothing special about this, obviously, is we're just running them and porting the output to a text file, which we'll use our main program in order to scan and parse. Okay, great. Now the long one. Win takes quite a while to run. This is actually dumping everything under HKey local system, software, Microsoft, Windows. So everything under Windows is being dumped here. That's going to take quite a bit of time, actually. What we'll do is we'll go take a look at some of our output, make sure that it's actually done correctly. Oh, yes. Sometimes when running VMware and you have the shared folders like that, you won't actually be able to see what's in the contents of the folder. I do promise you it is there, though. All right, great. So let's take a look at one of them just to make sure. How about our GP history? Yep. Great. It's populated. Looks correct. Good. Okay, once this Windows 1 is done finishing, we can move on forward. Actually, what we'll do while that's waiting is we need to go ahead and we're going to copy off the actual registry.pol file from our capture system. So that was under Mount FP, Windows, System 32, Group Policy, I forget the exact name, okay, it's Policy, not Users. Well, let's just go ahead and CD so we can take a look at what's there. Okay, so it's under Machine, and there's our registry POL. So we're going to copy it, but we also want to do a preserve timestamp on it. And we're going to copy that to our dump directory. Okay, great. So the reason we did that was we copied it over in order just to preserve the timestamp on it. We're going to correlate that timestamp at the registry POL within our database. We just don't want it as when we're performing this copy. We want it to preserve that timestamp of the registry.pol file from when it was actually created. All right. Okay, great. So it did copy it over. it did preserve the timestamp 8/18/11/12. Yep, that's right about when we did it, so that's excellent. So now all we need to do is let the win.txt dump finish from the win Redripper plugin, and we will have all our data in order to begin running our script. Okay, while this is going to complete, what we're going to do is we're going to go ahead and copy off our WMI repository so we can recreate that as it were on a test system. Okay, so we're going to go tar, CF. Let's make sure we know what directory we're in when we do this. So we're going to go mount. No, we want to go to our dump directory. Great. Now we're going to tar CF WBEM .tar, and from our mounted location, we're going to grab the WBIM folder. Beautiful. Okay, so the next thing we're going to take a look at is recreating our WMI repository. So what we have here is our basically blank Windows system. And we've also gone ahead and pre-downloaded some Python install stuff that we'll need here in a little bit. So just to show that it is a blank system, as you can see, work group. And if we look through WB or RSOP, you'll see most of this stuff is blank, which is great, which is what we expect it to be. Okay, we have a little VBS script, which is provided for you in the supporting documentation. It's blank. So that means that there's nothing within the WMI repositories at all that we can see right now. So there's two different ways in order to shut down the services that we need to shut down in order to be able to copy over the new repository. It's the Windows Management Instrumentation Service. You can either do this through the GUI, or you can do it the way I prefer, which is through the command line with the /y switch. It'll shut down this service and anything that is dependent upon this service. Great. So the first thing we're going to do is we're going to get to our WBEM folder, which is under Windows System 32. We're going to go ahead and rename the entire repository .old. Okay, interesting. It was the services.msc that was holding that folder open. Very interesting. Okay, so we're going to go to the backup copy we made of the target system repository. I'm going to drill down a little bit into here until we find the WBEM folder. It's always a good idea to drill in and make sure there's no preceding // on there. All right, we're going to go ahead and copy that entire folder over here. Now you have two choices here. You can either restart your services or you can reboot. I prefer to reboot because this is Windows. So we're going to go ahead and reboot the system, and then we should have a WMI repository of our target system replicated on this system, which we can then query. Okay, great. Now our system's back up. Since we rebooted, all of our services have been restarted. And we're going to go ahead and go back to our scripts. All right. Now, as you can see, it's generating all kinds of data. This is everything that was in the WMI repository on the target system. Sometimes this is not 100%, but sometimes you can run an RSOP at this point. And you would actually be able to see the system settings as they were on the target system. So as you can see, we're getting Windows 7, USGCB, Windows 7 computer settings, and more importantly, something in the source GPO at all, which obviously there are no group policies applied to the system. So great. Now we know that we do have it. We're going to go ahead and install some of our stuff so we can run our main WMI dump script. Of course, the main thing, of course, is Python itself. 3.3.2 is the particular version that we're going to be using. Okay, and it appears both the plugins we need are actually executable based, so there's no need for us to put the easy setup on there. Two different plugins that we're going to need, the PyWin32 and the WMI plugin. Always remember to run your plugins if they're executable based as administrator. All right, great. Okay, from here, we're going to go copy over our Python script, and we're going to copy that to our scripts directory, just for ease. Whatever your flavor is, to go ahead and run it. If you prefer running it from the command line, that's fine. If you prefer running it through the GUI, that is fine as well. There's very little verbosity in this script. It does essentially what the SQL one does. Okay, so what we're getting here is an access denied. So as a general rule of thumb, given the nature of what we're doing, we actually want Python to run as administrator. So I'm going to actually just launch the GUI. Can't right click and run as administrator. Okay, so we've set that to now run. We're going to go ahead and launch this. Open up our script. Now it should be elevated. Now we shouldn't have any problems. As mentioned, there's very little verbosity in this script. What it's doing is it's going to create two different things for us. It's actually creating an SQL file with everything it's finding, and it's also creating an SQL instruction file. The SQL instruction file is what we're actually going to use to import this information over to our main parsing script. Great. So now we know it's done. As mentioned before, it looks the same places that the VB script was doing. Registry policy settings. From there, it will pull out the GPO ID. And from there, it will select the registry policy settings based on that group policy ID. And that is it for dumping this information. That is all we need. Now the rest will be done by our parser. The last thing for us to do is actually copy over what was created by the Python script over to our dump directory. All right. And that's all we need. Now we can go parse. Last thing we need to parse out before we run our main parsing script is the registry POL file itself. In order to do that, we're going to use the LGPO utilities, mainly the import regpol file. So what we're going to do is run import regpol parse only, machine, location var POL file. We're going to log it. And we're going to output that to our dump directory as well. And we're just going to name this regpoll .text. That's it. It does all the decoding for us. And as mentioned before, it reads like an instruction file. So as we can see, it's starting to set keys. Looks like most everything will be a set command. There we found some that's a create key. We have a delete. And we have a delete all values. That's it. We now have everything in order to run our main parsing script. Everything's located within our dump directory. As you can see, these are the items that we'll be using. The other ones we've already used as they were needed. So here we go with the fun. Next thing we get to do is run our main parsing script. What I've done to make life a little easier on us is I've gone ahead and copied in the main script and the two supporting SQL files that it needs to complete, createviews.sql and usgcb.sql. The usgcb is a port of the usgcb spreadsheet. The create views is something that'll be ran very last in order to create some basic views, which merges all the data together. Just go through a real quick check on our files that we need. We got the regpoll dump. We got win.txt, the WMI information from our first script, policies, GP history, secedit, and Windows NT. Great. So let's go and run everything. Let's see, regripper files. So we're going to define policies, secedit, GP history. We're going to do WinNT, and then win. Next thing we need to do is tell it our actual POL file. Then the regpoll dump. The WMI SQL file. The USGCB SQL file. And the views SQL file. Verified all the files, and it's off to the races and starting to parse. As mentioned before, the first thing it does is it dumps out everything in the current tables if it's pre-existing. So if you do need to do it in broken up pieces, such as mentioned where you don't want to run the Windows NT and the win.txt parse, you would just kill the script at that point, copy your SQL file, rerun the script, and it'll rebuild everything for you. Okay, we're going to let this run for a little bit, and then we'll discuss things as they progress along. Some of these will go rather quickly. As it moved through and it did all of our SQL checks, now it got the timestamp of the registry.pol file. Now it's parsing our dump of the registry.pol file. Those usually don't take too long. Next thing it did was it ran wmiinfo.sql, which imports all of our WMI information from the script we ran first into this database. Now it's off and is doing some of our regripper parsing. Policies went very quickly. Secedit should go fairly quickly. The WinNT and the win will take a significant amount of time in order to complete, especially the win.txt. Okay, as you can see there, it went through our GP history. Now it is processing our Windows NT, which is 29,486 lines. That'll take a little bit of time to complete, but it's not too fairly bad. About 5 to 10 minutes probably on the average. So as you can see, it's now finally kicked over and it's running our win.nt, which is not showing a correct number of lines. It should be more in the 200,000 range. I'll have to take a quick look at the script and see what's causing that. But we're not going to sit here and wait for this to actually complete. So we're just going to go ahead and stop the video now, and then we'll move into analyzing the data, which is where the real magic happens. Last thing we're going to discuss is how to actually look at the analyzation of the output of the script. You're going to end up with 6 tables within your gparsing.sqlite database: gphist, secedit, usgcb, import regpol, wmiinfo, and allwin. gphist is the regripper parse of the gp history, secedit is the regripper parse of the secedit, usgcb is the port of the usgcb spreadsheet, import regpol is our parsed POL file, wmiinfo is everything we got from the rsop registry Python script, allwin is everything else that we dumped. That includes everything in the Windows, Windows NT, and the policies, hives. A little more detail. Allwin, gphist, import regpol, secedit, and wmiinfo all contain columns for the hive, key type, and the value. Allwin, gphist, and import regpol contain a column for the hive time. Allwin and secedit have a reg multi-binary and reg multi-text columns. These were created because when you actually read each line of the output within the regripper output, the binary will be on the left-hand side and the text will be on the right-hand side. So we've separated those out, put those each in their own column within the database, and a custom new line character has been added, which is NL. All the tables contain a column setHive, which has been modified by a parsing to match the registry info section of the USGCB spreadsheet, which has also been parsed out to meet setHive. Another important note is within the USGCB spreadsheet, in the registry info, you're going to have multiple hives. We have split all those out so they each have a unique setHive column within the USGCB table. This column setHive can be used to merge tables through a join statement and is the key indicator when you're merging data in between your different tables. Import regpol and WMI also contain the instructions column, which is related to the POL instruction. Set key, which is not an actual value, create key, delete, and delete all values. The wmiinfo also contains a command column, which is the instruction command similar to what you would expect in a POL file, but the actual command is not issued within the POL file. It is contained within the policy section of the registry. Allwin is used to tie back expected versus actual security. This table is a literal dump of the Windows, Windows NT, and policy settings. So this is what you would do once you've identified what your policy is set. You would tie it back to this in order to check the expected versus actual security. There have been several views provided for quick analyzation. My effort was to contain all the information needed in the database, not to provide the views and the formatting of the data. There are too many ways for somebody to look at and interpret the data depending on your purpose and scope. Some of the provided views that you've received, WMI and USGCB, joins wmiinfo and USGCB on the setHive column. This is going to basically show you what was defined in the WMI dumps of your data, and that's going to correlate what was set based on the setHive back to USGCB. So this is going to show you what policies were defined that we found in WMI and correlate that back to the USGCB settings. It's going to give you a full view of the information. It will give you both the WMI information, so the actual registry value, and it'll give you the USGCB suggested settings, comments, and everything else. WMI not in USGCB, exactly the opposite. It's anything that was defined in WMI that was not found within USGCB. IRP in USGCB joins the import regpol in the USGCB on setHive. This gives you the same perspective, but only from the local security policy via the POL file. IRP not in USGCB, same thing, only not defined in the USGCB. We've also provided GP timeline, only works within the GP history table, sorts in the correct order by time, hive, and key. This only identifies which group policies were applied in which order, but the idea is that you could cross-reference this versus what was found in WMI info, and then of course correlate that back with your all-win table to check the actual versus expected security. No views have been provided to correlate the policy set values with the actual registry values, since the processing of Windows NT plugins take considerable amount of time. One should typically first perform an analyzation to have an idea of what you're looking for, and then perform a validation of those settings. So final notes. I unfortunately didn't have time to do 100% validation of everything that's dumped versus what was expected due to the sheer size of the data, but I did do several spot checks and they seemed accurate. Most of them even surprised me. One would assume, since we're using the NIST provided POLs and group policies, 100% of what was actually set in group policy would be reflected in their spreadsheet. That's not always the case. An example, just one random example, which is a turn off sidebar. That was something that was applied via the NIST POL file, but was not defined in the NIST spreadsheet. That kind of confirms one of the concepts of what we wanted to meet as an objective, which was enhancing the USGCB spreadsheets. My hope is that the data extraction speaks for itself, and placed in capable hands can be used to meet all the outline objectives. Out of the provided views, the most reliable is the WMI in USGCB and the WMI not in USGCB for compliance correlation. A scripted solution or a better SQL method would be far more effective, and starting with the group policy history and working backwards on similar data. So hopefully the data is there for everybody. You need to apply your own intuitiveness and creativity when processing the data. So I hope you all enjoyed this journey through group policy on a system level as much as I did. I plan to continue to refine this solution into an actual product. If you have any interest or perspectives that you wish to share or bring to the table, please feel free to contact me and do so. I thank you all.